All right, thank you, Chairman. I would like to introduce myself just a bit. My name is Fabian, come from Indonesia, just next to Malaysia. Uh, I'm actually wants to share some of our experience. We've been partnering with SuperMap for the past couple of months, so starting by this year. Actually, last year they invited us also, but the actual work with the students and all things that we can share today happens this year, so 2024. So we have this kind of program and enrichment programs, which I would like to share also, because we have lots of data that needs kind of collaboration with SuperMaps. This is our campus, one of the campus. We have the city scale LiDAR data, which we currently have a problems of, can we have a platform that's showing it really fast and with the reasonable price range. So that's kind of things that we will discuss today. So just a quick introduction of our university. We have 50,000-ish students. We're from computer science, but we have 90% employed of graduation, and this is just the numbers and stuff. And then we work with 240 plus universities and 5,000 companies. One of our partners is here also. But in general, since we belongs to School of Computer Science, I'm actually a geodetic engineer, but I believe that the future of this technology is gonna be in computer science department rather than in actual surveying department. So this is why I believe that we're building this lab in computer science to get the most, the most resources from the students. So students that already knew how to write Python code, the students that already know JavaScript, those things, we level up the game of GIS. So that's what I believe in. So we built this lab on the computer science department. We got 12 programs that include the game department, cybersecurity, include statistics, mathematics, data science, and all of that in computer science. And in terms of nationwide, we rank number 2 after University of Indonesia in the world rank with 351 to 400-ish. Yeah, so that's the rank. But that's in terms of computer science department. We got 7,000 students working in that. And we're not from a GIS or geography department, but we have 250 students every semester learning GIS. They belongs to the big data, they're learning big data and cloud computations, but they actually learn GIS. So we have 250 students that already know how to code, that we can build this lab from it. So the idea, it's to work with SuperMap at the end of their academic careers in the semester 6 or semester 7. They have 1 year full of internship. We got internship track and research track. We have been working with SuperMap for the past semester. We currently have 2 interns working with a real project by SuperMap Indonesia. They're working with the real projects, and we got 89 students. It should be 90, but it's 89. We call it research track students, which is they have their own topics or their own supervisors, and but SuperMaps keep looking for them, asking for their updates, if they can use the dashboard, if they can use the application, if they can build the models, and so on and so forth. So we call it research track students, and we combine that with the TSA program, which is coming from the Minister of Education. So I believe this is our first semester, and if we can do this, I think the growth will be exponential for us, for the students, and to build this lab, the geospatial lab, the GeoAI lab in the computer science department. So this is our lab. We call it RIG. It's under rectorate. So we mainly work with geospatial data and financial technologies. But me belong to, because I'm a geodetic engineer, so I belong to the GeoAI lab. We have computer science. We have information science systems. We have mathematicians, statisticians. We have civil engineering. We have architecture. Also, we get helps from the business people, management, design, and visual communications that helps us together to build a strong GeoAI lab. So that's what we believe in. And from this past 2 years, we just established in 2021, it's 3 years ago. But since the term GeoAI, it's kind of a hot topic for a couple of years ago, but still currently a hot topic. So lots of government agencies trying to approach us. We have been working with the provincial government because we located in Jakarta, in the capital of Indonesia. We work with the Bank of Indonesia also. They want to calculate the carbon, the blue-green economics, and also with the Palmco. It's the largest state-owned palm oil. We work with that, which I will show you one of the dashboard we made, and then some of the technologies from the SuperMap that already built from them. So, and then just this morning, we scanned some of our campus with Leica laser scanner. We test their handheld laser scanner, and we want students who's not geodetic engineer, who's not surveyors, they're computer scientists, and they should like holding the scanners, and then they see how the 3D scanner works and how to work with point clouds and so forth. So we believe that the computer scientists will work faster in this kind of data stream. And we're starting on Q1 2024. We work with SuperMaps. Before we work with SuperMaps, we almost never use pre-built models. So the students always develop their own models. If they want to, let's see, I want to count the number of trees, then we build our own models. If we want to, so this is, in 2019, 2020, we got hit by earthquake in the east part of Indonesia, and we want to check if some buildings is impacted or not. So we built our own models. We never know that there is some pre-trained model that's good enough rather than we build ourselves. So we always build this. So this is a computer science perspective. And if we want to do something, just build our own model, just test so many models. And then we start to change a bit, of course. Still, we work with our own models, but we compare it to the pre-trained model. Let's say SuperMap has this kind of models, and then we try to use our own compared to SuperMap and what's missing, and we try to improve. And then we're currently trying to think a way if we can display it in SuperMap clouds, let's say, or using some services that SuperMap has, which we have access now, and then we can use it at least to make our data set publicly available. And if you see just building models, retraining models, trying to get the very low loss functions and stuff. But this one we built, this is the national monuments, level 3 details. This is all built by computer science. We call this computed, it's a CGA. It's kind of language that we want to build everything in 30 minutes. So if government have very good data, we can build everything in 30 minutes. But then we don't know how to like show it in the GIS platforms. So that's the idea. Many of us doesn't know what is the coordinate systems and so on and so forth. So that's our thing. And then this is nationwide high-level deforestations using machine learning. This is actually deep learnings. We see there are some patterns like the people. Red one is they open by company. The blue one is opened by the people. So they have distinct spatial patterns, which deep learnings can separate between that. So we know that the deforestations in the east part of Indonesia, it's not because of the anthropogenic activities, but because of the companies who's opening really large areas of plantations. So we cannot blame people, we blame the other stakeholders. So that's the idea, using deep learning to differentiate that. And tree detections, I guess some of the great speakers already talked about tree detections, but we simply built our own models. We do not use pre-trained models. And then that's palm tree also. We propose a method. It's a deep how to say, it's a self-supervised method. We can just call it self-supervised, but it's actually multimodal and then just retraining again. So like we always just build these models. So this is just some of the case. we got the knowledge of which one is the healthy plants, unhealthy plants, and then it's just me here. Mrs. Santi is there, and then we have this knowledge, and we put the labels, build the dashboard, and then we just build the model. So this is it's actually very simple. We want to do semi-automatic tree countings, and then from the counted tree, we differentiate into abnormality and it's a normal abnormals, because sick plantation, it's much more parameters. We don't know what kind of sickness this plantation has. These two, it's unhealthy, but they have different types of sickness. So we just per normally, it's normal abnormal. So that had been as a standard. They have those really detailed, but in general, we use SuperMaps also, and then we try to compare the algorithm that they have, the pre-built models. This is the basic RCNN, Cascade, and DMM that it's a Cascade also. So so we compared it to several of our models, PSPNet, UNet, ResNet, and lots of deep learning models, just to see which one performs better. And then we just put it there for public to see and then compare. And we give it to the company, the Palmco, to see that if you have a dashboard, you save up lots of dollars just to do that using drones, which they also have to have a good data because of garbage in, garbage out. So if they have a good drone data, a very stable data inputs, then we can reuse the model. If not, then we have to retrain the models. So this is basically last year or 1.5 years ago. The government needs the professional government approached us. Can you build some 3D models that's fast enough, right? So what kind of data do you have? We have the building heights, we have the footprints, we have the types of windows, the colors, and so forth. Okay, we just use something called the CGA, computer generated architecture. I think some of you might know this kind of language. So it's a shape grammar. So instead of we build one by one, we just type the parameters and then builds by itself. Of course, some of the point of interest, like the churches, the national monuments, that's a really big church, that's a really big mosque, one of the biggest mosques in Indonesia, Istiqlal, and then some churches, the cathedral, and then some of them. And we use also the tree based on the species. So they have a sample of the species. So we put it there. But now we don't know how to do this like spatially correct. We don't know how to use like a correct coordinate reference and so on and so forth. So in terms of visual, it looks good, but I don't know if it can be used as a digital twin yet or not. Yeah. So that's two different things. Yeah, we can build this in 30 minutes for the entire. It's not that big in terms of it, but it's fast. So that's the idea. It's 6 students with 2 supervisors did this. And then just this morning, we scanned some of our campus with Leica. This is just this morning. So we put it like that. And then we have built the 3D models. We got help by some of the students from the game department. So actually using the game engine here. And then we have the metrics of the objects by using the LiDAR sensor. So we got that, and we just put in the building management. So the building management used to like put the QR code here, a QR code here, so they can just select and see where these guys are going now. So you just see, it's just to help the building management and so. It's not yet BIM in the sense of building management. It's not yet there, but in terms of computer science, it just looks good. So there's a gap between how the computer scientist thinks and works, and then these so-called BIM. So we're onto that directions, but still we need to work with the architecture department, with the civil engineering and stuff. But this is our goal is to create a good games for students. So before entering the university, they can play games, how like seeing the rooms of university and finding some brochure, and then if you get points and so on and so forth. So it's just for games. Just can I play this? Yeah, they can turn on the lights. They can see if they sit in this chair, what's my perspective. If I sit this chair, then can I see my teachers? Can I move the chair? So it's basically game engine. But I believe that SuperMap has this platform to show this because we see. So we're trying to integrate these all the metrics we have and to make this a really good game with the SuperMap platforms. So that's the idea. This is some of the rooms in our campus. Yeah. So it looks cool, but I think it's cooler if we can use it as actual building information management rather than like showcasing. Right? I think so. We do have several. Yeah. So for future collaborative directions, I would say technological knowledge and access sharing will be very good help for us, as we don't have too many geographer. I'm a surveyor in a way, but sharing the technological knowledge, it can use the SuperMap technologies to process or as computing platforms, or just to visualization and show this to publics, or else we can recommend this technological stack for stakeholders, let's say governments, which most of you in this room is doing it. We recommend this technological stack if it solves the problems. And also the ABCGM, as you know, our universities has been approached a lot by the governments. They do the focus discussion groups, so on and so forth. So if the SuperMap can help us with that, it's gonna be really good collaborations. Other than just publishing papers and research track and internship students, professional service could also consultations and stuff could also work. But last but not least, we have lots of data. We have lidars of our campus. We have oil palm plantations. We have the point clouds of our campus, which we need to work and utilize. And then I guess some of technological stack from SuperMaps could help us in a great way. So I think that's all. Thank you so much, and have a great day. Thank you.
Thank you for being